Hi, my name's Fred Zelt. I'm a geologist in Pittsburgh, and I'd like to share with you some great stone buildings in Pennsylvania and beyond, their geology and landscapes too. Let's get the screen share going. This talk is about Lynn Hall and Port Allegany, sandstone, glass, Allegheny Modernism architecture, and echoes of Frank Lloyd Wright in McKean County, northern Pennsylvania's so-called driftless area. This talk was given a few days ago in Kane, Pennsylvania, with hosted by the Kane Historical Preservation Society in the Thomas L. Kane Memorial Chapel, which was first built by Thomas Kane as a Presbyterian church and is now beautifully preserved. I'd like to thank Lisa Olzak Zumstein for help with getting the projector and the laptop to work together during the talk a few nights ago. This talk was first given about the geology of Lynn Hall at the annual meeting of the Field Conference of Pennsylvania Geologists held in Williamsport over a month ago. At the end of the talk, I'll show you where you can find a link to the guidebook for a pre-meeting trip for the field conference, and the talk resulted from that. So you'll be able to find a reference online, a free online reference with some of the slides here and a lot more explanation. I've had a lot of help in understanding the geology of these sites and access to them, not only current and former owners of Lynn Hall, but folks living in Port Allegany, including people who own Raymond V. Hall designed sites. Special thanks to Doug Hall, a descendant of Walter Hall and Raymond V. Hall. Then there are lots of folks beyond northern Pennsylvania who've helped me understand aspects of Frank Lloyd Wright architecture that are relevant to better understanding these great sites. And I've had help in the geology research, including by folks with the Pennsylvania Geological Survey, as well as reviewers of that chapter in the 2025 Field Conference of Pennsylvania Geologists Guidebook. Thanks to the individuals and organizations also who've allowed sharing of their images. Here's a geologic map to set the setting. The colors on the map are different geologic ages of bedrock. You can see that Taliesin to the west there is an area of Cambrian and Ordovician age bedrock. The bedrock for Taliesin itself is a Cambrian dolomitic sandstone. Then you can see Graycliff on the east shore of Lake Erie, south of Buffalo in western New York. It's in an area of Devonian bedrock. Lynn Hall in northern Pennsylvania is an area of Devonian to Pennsylvanian age bedrock. I'll talk a little bit about Falling Water and Kentuck Knob in southwestern Pennsylvania, and there's lots of Pennsylvanian age bedrock there. Note the dotted white line around Lynn Hall, south of Graycliff. That's the limit of Pennsylvanian or Pleistocene glaciers, as far south as glaciers came through Canada and into the United States in the last 2.6 million years. You'll notice Lynn Hall had glaciers that came to the east, north, and west of it, but not there exactly. Same with Taliesin. It's in an area surrounded by that dotted line. It's the so-called driftless area, glacial drift being glacial deposits. And it's in an area that was at times surrounded by glaciers, but never overrun by glaciers. And it left a special terrain there. More hills, valleys not filled in by glacial deposits, typically flat-floored valleys with abrupt hills, and some similarities there between Taliesin and the landscape at Lynn Hall, as we'll see in a few minutes. Here's a closer view. You can see the outside outline of Pennsylvania. You see Port Allegany with a yellow dot, also Kane, where the meeting was held. And the black dashed outline is the outline of McKean County, which includes both Kane and Port Allegany. Both are in the unglaciated high plateau ecoregion. I'd like to draw an analogy between the geology I'll be talking about and snowflakes. First came up with this analogy when I gave a talk about the geology of Graycliff at the Darwin Martin House Visitor Center in Buffalo a few months ago. We all know from experience that there are different shapes of snowflakes. There are ones that are really lacy shapes. There are ones that are tiny little crystals. And we know from experience that different temperatures can result in different kinds of crystals. A really cold night we might have those tiny little crystals that people call diamond dust. This plot shows that there's a relationship between air temperature and water saturation and the types of snowflakes that we get, the thermodynamics of snow, in that different sites on the ice crystal are favored at different temperatures and water saturations. There's even a field guide to snowflakes written by a Caltech professor. But we don't need to understand the thermodynamics of snowflakes to appreciate them, to understand there are different types of flakes in different conditions, and to enjoy walking through a meadow that's had a dusting of snow on a really cold night. The sun comes out and there's sparkles of diamond dust all around us. We don't need to understand the thermodynamics of snow to appreciate it. The same thing with building stone and the geology. We don't need to understand the geologic terms, the concepts, to appreciate and observe that there are different shapes, colors, textures of stone that were used by the architects in their buildings. So we certainly can appreciate snow, and we can appreciate the geology of these sites without the thermodynamics of snow or remembering the geologic terms I'll be talking through. We can just appreciate the views that we see of these sites. I'd like to give a little bit of background about Frank Lloyd Wright and his architecture. These are the 8 sites that make up the UNESCO World Heritage Site of Frank Lloyd Wright buildings. And they're in chronological order from the upper left to the Guggenheim in the lower right. I'll point out with the red outlines buildings that have significant stone components. In the top row, there's Taliesin, Frank Lloyd Wright's test bed of developing organic design concepts in southern Wisconsin. Started in 1911. It was modified with additions, changes through the rest of his life as a test bed until he passed in 1959. In the lower left is Falling Water in southwestern Pennsylvania, built cantilevered over a waterfall. It's widely regarded as the masterpiece of Frank Lloyd Wright organic design. And then in the bottom row is Taliesin West in Arizona, built as a place to go in the winter for Wright and the fellowship members. It also has significant stone component boulders being built into the walls. And I'll just point out that the 2 buildings Wright built for himself here, Taliesin West, during as an adult architect, a mature architect, both have significant stone components. I'll talk mostly about the geology of stone buildings here, Hall buildings and Wright buildings, but I would like to point out 2 more. The Roby House was chosen as the example here in the UNESCO sites of a house representing Frank Lloyd Wright's prairie style period. And we'll talk about that a little bit. Then below that, here, the Jacobs One House in Madison, just about 30 miles east of Taliesin in southern Wisconsin, was Frank Lloyd Wright's first Usonian house. Usonian, a term he coined meaning United States of North America. They were meant to be relatively modest in size, affordable houses, but very beautifully designed. And this was the very first one of those by Frank Lloyd Wright. It was designed in early 1937. Construction continued through the second half of 1937. So that 1937 date will become important to us later on, and that this is the example, the first one, Jacobs One House. Those 3 that I showed with stone components aren't the only stone buildings Wright built. You can see in the upper right, Hillside, now on the same grounds as Taliesin in southern Wisconsin. You can tour both Hillside and Taliesin. Hillside original part of it being built for his aunts as a school during the prairie style period in the early 1900s, with later organic architecture additions to it. There are some other stone buildings that Wright built during the prairie phase before Taliesin. He had a stint in Japan in the late teens and 1920s. Some of those buildings included significant stone components. It was Oya stone. It was a vesicular tuff, a volcanic rock with lots of air holes in it, giving it a texture. And those were highly carved and smoothed blocks, different than the rough-shaped organic design stones that we'll see at Gray Cliff and later on. Gray Cliff on the shore of Lake Erie, south of Buffalo, was the first house Wright built for a client in North America using the organic design concepts he had been developing at Taliesin. And as you see, it's a blend of prairie school lines and features along with organic architecture. We talked about falling water as a masterpiece of organic design. I won't talk more about Taliesin West, the one shown below, falling water. I haven't studied that one yet. I'm hoping to go there in February this year and study the geology of the building stone and the terrain there. Kentuck Knob, though, we will talk a bit about that in southwestern Pennsylvania, built late during Wright's career with stone walls and stone pavers, too. I talked a little bit about prairie school versus organic architecture, and I'd like to convey the way I'm thinking about those terms and styles using windows. There's the Roby House, an exemplar of prairie school architecture that's in the UNESCO World Heritage Site. Often when we think of Frank Lloyd Wright buildings, we'll think of these gleaming oak interiors, beautiful furniture, and these art glass windows like the ones shown here with highly artistic designs incorporating stained glass. People love these art glass windows. You can see in the evolution of windows here, I mentioned Graycliff was the transition between prairie school and organic architecture for Wright. And we can see the main natural feature of the house, Lake Erie, through the dining room window here. But the architect, has still chosen to provide a picture frame around that picture window. In contrast, there's a corner window at Falling Water. There's no metal support in the corner. It's glass on glass. It's a mitered glass cornered window, and it really blurs the boundary between interior and exterior. Then there's Kentuck Knob, built late in Wright's career. The living room window glass is set right into the stone. There's no difference between the interior and exterior walls here. And standing at the right angle when there's no reflection in the glass, it just doesn't look like there's a window there at all, really blurring the boundary between nature and the interior. I'd like to talk for a few minutes about some theory or philosophy of organic design. I had been thinking before this year of organic design, it being really important to incorporate natural materials like stone and wood. But the scholarship of Kevin Newt, who is teaching in university in Hawaii, really affected the way I think about this, and I wanted to share this with you. I was lucky to spend a couple hours on the Falling Water grounds with Kevin in June while he was a visiting scholar at Falling Water. His work is available in books. He studied the architecture of Japan. He's a Frank Lloyd Wright scholar as well. He has books out, plus you can find his talks on YouTube, including a Falling Water webinar he gave on this topic of organic architecture in June. I'm going to illustrate these concepts of Kevin's that I've learned using scenes from the Adirondacks in springtime. There's a fiddlehead fern. It's a beautiful design. Just like each of us, each of these natural elements is unique. Each of us is unique. Each of these natural elements is unique. When we compare it with other fiddleheads in detail, they're each a little bit different, but they combine to form the art of a forest floor, a carpet of ferns on the forest floor, combines with other elements to form the tapestry of the forest floor. And then with more elements, trees, for example, may be the same species trees, but each has somewhat unique design of branches and leaves. And all those individual unique elements come together to form the whole. Just as we'll see building stone in these Hall-built buildings, Walter Hall and R.V. Hall buildings, as well as Frank Lloyd Wright organic architecture buildings that use stone. Each stone may be a unique element with a hand-chipped edge, may have fossils, it may have mineralized crusts on display, different sizes and shapes. Each stone may be unique, and it becomes part of the greater whole of the wall or the floor, a part of the greater whole of the building. Two other aspects of organic design are important, and that Kevin has talked about. One is these things change with time. That fiddlehead fern will look different a week later. Things change a lot. Imagine being here in the fall. It might change even day to day. So another element of organic design is that things change with time. And sometimes when Frank Lloyd Wright would be asked by clients of their newly built houses, how to treat the exterior to keep it from changing, he would say not to treat it, that it was meant to change. So the copper-colored roof of Kentuck Knob turned green naturally. There's an iron oxide patina on the outside stones at Gray Cliff. It's a natural thing. You see that on the stones at the beach too, that were harvested for the walls. And wood, he suggested, might be allowed to turn gray on the outside. Not all owners honored that. Some did treat their wood so that they wanted it to look new, but that's one element. There's another element here. You'll see lots of shapes of stones, and there's form without function. You know the concept, I'm sure, form follows function, and that's not it with this. There actually is form without function, without a purpose. It's pure form. Okay, let's look at some examples of those concepts uh, as they were built. We'll start with Taliesin in the west, and we'll work our way east, and we'll start with the oldest, and it'll be a chronological view too. There's a chimney mass, old part of Taliesin. The building stone there comes from a quarry a mile away. It's all originally golden brown, dolomitic sandstone, Cambrian in age. And Wright observed ledges in natural outcrops and quarries and wanted to mimic those in an artistic way in the stone walls, both interior and exterior. And so he insisted on there being stickouts where some of the stones jut out a little bit from the mortar. So you can see that natural organic pattern of the stonework there, and each stone being unique but part of the greater whole of the chimney mass. The next one, Gray Cliff, a transition for Wright between Prairie School and organic architecture. Most of those wall stones are from a 1.5 foot thick layer, Middle Devonian limestone, full of fossils with natural fractures that were in the cliff above the lakeshore beach. As the cliff retreated, blocks, boulders of the limestone ended up on the beach, got rounded. Then they were carted up to the house site, split. Sometimes the split surfaces are shown, and you can see they're full of fossils, traces of life. Sometimes the naturally rounded surfaces were shown. In the center is a metamorphic rock that was carried down from Canada by glaciers, was on top of the bedrock, also ended up on the beach, then is split and on display. And notice the iron oxide patina that's come through time from weathering of pyrite. So every stone in this wall is unique, but it's part of the greater whole of the wall, part of the greater whole of the house. You can see the long lines of the house. You can see Lake Erie through the house there. Now let's look at Lynn Hall, built by Walter Hall in Port Allegany, northern Pennsylvania. And we can see a view of an exterior wall of the core, the original part built. The exterior walls like this would have been built before Walter Hall served as falling water builder in 1935 and early 1936. And you can see it's a very pleasing tapestry of slabs and blocks. The slabs are olive gray, darker in tone, quarried from the hillside behind Lynn Hall. The blocks are a younger Pottsville sandstone, lighter in color, lots of different sizes there, and natural finishes, chipped finishes on the front. Then when Walter Hall became builder at Falling Water, here's one of the walls that resulted. This is from a view from the driveway just beside the main house. And you can see that it has the sort of blend of blocks and slabs that Walter Hall was used to building. In fact, that's thought to be one of the reasons he was hired as builder, was because of the excellence of his stonework, as shown at Lynn Hall here in the core. But also it has the stickouts that Wright insisted on to mimic in an artistic way natural ledges of outcrops and quarries. Here we have another view of, on the right, interior walls, on the left, exterior walls. At Falling Water, you can see the function of these stickouts as aesthetic features. Falling Water sandstone was quarried from a 6 foot thick layer, about 600 feet from the main house, in a quarry there on the grounds. It was all originally light gray in color with some mineralized surfaces, but mostly light gray. So the stickouts allow us to see the stonework from some distance because of the shadows underneath, mimicking ledges in a natural outcrop in a beautifully artistic way. There's Walter Hall with his son R.V. Hall, budding architect at this time in 1939. during construction of the guest suite and the staff quarters, along with the pool at Falling Water. Notice that they're next to slabs of sandstone from the quarry that are about to be laid as pavers on the terrace. Also notice the stickouts in the main house down the hill and in the pool too, and how the shadows help you see the nature of the stonework, those long ledges mimicked in the stonework. The house in the distance there was built in 1936, the exterior, 1937, the interior. Then there was a gap year, 1938, no construction here, with the building in the foreground, the guest quarters, staff quarters being built in 1939. So that timing will be relevant to us as we talk about Walter and R.V. Hall's work in Port Allegany and beyond. We'll pick up now with the corner of the main house wall that we saw earlier, built in 1936, the exterior of the main house at Falling Water. And then during that gap year, Walter Hall added to the core. Here's part of the addition at Lynn Hall. You can see still have the nice blend of darker flagstone slabs and lighter sandstone blocks, but this time now there are stickouts on the exterior. And then there are buildings, 1939, 41, 47, designed by R.V. Hall, certainly, or some of them likely built by Walter Hall. That same signature blend of Walter's of slabs of darker flagstone with lighter colored blocks, sandstone blocks in 39 and the 1947 houses. The 1941 house, though, near Lancaster, those blocks are metamorphic rock. Those are from southeastern Pennsylvania, where the rock at the surface there, many of the rocks at the surface were once very deeply buried, so deeply they recrystallized. So those blocks are micaceous quartzite and nice metamorphic rocks, not the sandstones of other buildings. And then in the lower right, we can see Kentech Knob, built late during Wright's career. It's built of Pennsylvanian sandstone that was split from boulders on another property that clients, the Hagans, owned about a mile away as the crow flies, kind of up the valley there. And built into the walls are different sizes and shapes of these building stones, the sandstones, and stickouts. So those continued, that theme continued late into Wright's career. Walter Hall and R.V. Hall were fans of Frank Lloyd Wright buildings. And for Walter Hall, that had gone on for a long time before Lynn Hall was built and before he was builder at Falling Water. There's the Darwin Martin House, available for public tours in Buffalo, a beautiful brick prairie style house built by Frank Lloyd Wright. And you can see in the upper left a quote from a letter Walter Hall wrote to Wright at the end of May in 1936. This letter was a response to a letter from Frank Lloyd Wright to Walter Hall, asking Walter to consider becoming the builder at Falling Water, in part because of the excellent stonework that had been seen in the core of Lynn Hall. Hall wrote back to Wright, having followed your work for a period of 30 years, your letter came as a very pleasant surprise. So 30 years ago, in 1936, was about the time Wright was building 4 prairie-style houses in Buffalo, as well as a high-rise building. And Walter Hall is thought to have actually seen Frank Lloyd Wright on a construction site, although he didn't choose to go up and introduce himself. But he certainly was a fan of Frank Lloyd Wright buildings. And the ability for Walter Hall then to have gotten to Buffalo easily was facilitated by a good straight rail connection through Port Allegany to Buffalo. Lots of cultural ties between those two. Notice Lynn Hall at the bottom, not prairie style. It's a modern style. It's Allegheny Modernism in style. These long horizontal rows of windows. But notice the entrance is in the core on the right, the original part of Lynn Hall, built both before and during Falling Water. And it juts out a bit from the main building. Some people would say sort of like as exists at the Darwin Martin House, where the entrance is in the part that juts out a bit from the main building on the right. And again, the addition of Lynn Hall on the left was built during the construction of Falling Water, so after construction of the main house and after falling water. Wanted to show a comparison between the map scale footprint of Taliesin and Lynn Hall and where they sit on the terrain. So those four maps at the top, they're all the same lateral scales. Shaded relief map on top, a topographic map for the area around Taliesin and Lynn Hall. And you'll notice that both of them sit midway up a hillside or a mountainside, not at the crest, not at the base. Frank Lloyd Wright wrote about that as a preferred spot for these buildings. He did that at Kentuck Knob too. It doesn't sit right on the crest. It's built into the hillside. This was a feature of his with organic design. Same thing with Lynn Hall. It's built into the hillside. And you can even see the pictures on the right. Taliesin overlooking the flat-floored Jones Valley with moderate hill slopes in the distance. Same thing with Lynn Hall in this historic photo, overlooking the flat-floored Allegheny River Valley with moderate slopes of hills and mountains in the distance. Trees have grown up now on the other side of Route 6. You can see the highway of Route 6 in the photograph. So similar terrain, and both in areas that glaciers, continental scale glaciers, didn't overrun. So these hills weren't planed off by glaciers. The valleys weren't completely filled in with glacial deposits. Instead, the valleys are partially filled with deposits of glacial age, including lake deposits when north-flowing rivers and streams were cut off by glaciers dammed up, lakes were formed. So part of these flat-floored valley sediments are those glacial lakes in front of the main continental scale glaciers. Similarly with the footprints, notice the footprints at the bottom. Again, those two maps are the same lateral scales. And Wright wrote in 1954 that his preferred orientation for the footprint of a house was to have one side of an organic design house be between 30 and 60 degrees azimuth to north. So with north being straight up, Taliesin has this side at about 37 degrees relative to north, and then the other side, of course, 90 degrees to that. And as I understand it, part of the reason for that was so that each side of the building at some time during the day, in morning through midday or late afternoon, each side of the building would receive direct sunlight. And notice Lynn Hall has an azimuth here of 50 degrees within that 30 to 60 degree range that Wright later wrote was his preferred orientation, and then 90 degrees to that. So both built into the side of a hillside and at those oblique orientations relative to north. Let's look at the terrain around Port Allegany. And this map is pretty helpful for us to understand the terrain a little bit better. I'll first point out that you can see the major cities, Buffalo, Pittsburgh, Philadelphia. Port Allegany's closer to Buffalo than any of those. I mentioned before there was a direct passenger rail connection starting in the late 1800s into the 1900s between Port Allegany and Buffalo. And there were a lot of cultural ties between the two. I'll talk about the glassmaking heritage, and that goes to present day glassmaking in Port Allegany. Some of the owners of early glassworks in Port Allegany lived in Buffalo. And there are a lot of cultural ties. When television came along before cable, people in Port Allegany, I'm told, got Buffalo stations. Down to this day, I can tell you that there are a lot of Bills fans in the Port Allegany area today. And the shape of the map, it's an elevation map of the surface. And it's really shaped by a continental scale collision that happened between Northwest Africa and the North American continental plate about 300 million years ago. The area of Philadelphia in the southeastern part of the map was once the root of a really tall mountain belt. May have had mountains as tall as the Himalayas from that continental scale collision around southeastern Pennsylvania. And then in front of that, their sedimentary rock layers were compressed and folded. You can see the folds of long valleys and ridges in the Appalachians going through central Pennsylvania and adjacent states. At the Allegheny front, that intense folding changes to more rumples in the folds. Chestnut Ridge here in the lower highlands, 1,000 feet amplitude, a couple thousand feet here for Laurel Hill, upward folds, falling water sits in a downward fold. So in the plateau area where the rocks are more flat lying, they're still folded with larger folds here that damp out to folds with amplitudes of only hundreds of feet into the lower and flatter part of the plateau. So there are folds from that tectonic event 300 million years ago going through the area of interest to us, but they're not as intense folds as the ones here in the Valley and Ridge province in the Appalachians. And you'll notice the white line for the limit of glaciers, Pleistocene glaciers, and that Port Allegany is right at the limit of any of those thought to have possibly extended um, in the driftless part of Pennsylvania. Here's a little more terrain, a close-up view from the red box in the last view. You can see Port Allegany in the upper left part of the map sits at the end of a portage, canoe portage between Susquehanna River watershed and the Allegheny River watershed. This was an ancient transportation corridor from prehistoric times into historic times, 1700s. Into the 1800s, people were using canoes for transportation on these river systems, and the Allegheny River being the route west, flowing first to the northwest and then turning to the southwest and toward the interior. So it was an important transportation spot and was called Canoe Place for a long time, associated with that portage. When the railroad came along in the late 1800s, followed the same route through Port Allegany, and as I mentioned, provided a direct connection with Buffalo. The heavy gray line indicates drainage divide between the watersheds, and this is a special region because you can see in the red diamond, there's a triple divide. It's the major triple divide east of the continental divide in the Rockies. So east of that, this is a divide between the Allegheny River watershed, the Allegheny River flowing to the Ohio, to the Mississippi, then the Gulf Basin, the Genesee River watershed, Genesee flowing north to Lake Ontario, St. Lawrence Seaway, and then the North Atlantic, and then the Susquehanna River watershed, of course, flowing to Chesapeake Bay in the Atlantic. So a major triple divide. Another feature of the terrain here I'll point out is Pine Creek Gorge. Notice how you can tell from the tributaries pointing downstream that this stream system has always flowed to the southwest. This stream system, shown by the blue arrows in terms of the current flow of water, this stream system used to flow to the northeast. You can see that from the way the tributaries point, but this part of it now has been reversed. In glacial times, glaciers stopped this drainage, created a lake, overtopped a watershed divide in this area, and eventually, during glacial time, the stream cut down, cut a V-shaped young valley of glacial age, Pine Creek Gorge, known as Pennsylvania's Grand Canyon. And I'm talking through that in a little bit of detail because it's such a great feature in this region. And it was a feature of the field trip, an optional stop in the field conference of Pennsylvania Geologists pre-meeting trip that focused on Port Allegany and Lynn Hall. But also, I'll show you another part of the terrain west of here that's a similar feature where a drainage divide was overtopped, cut down with a relatively steep and young valley. Okay, we've talked about the terrain a bit. Notice the yellow line here connects Port Allegany with Williamsport, goes past Roulette in western Potter County, and also past Barber Rock Overlook of Pine Creek Gorge. That yellow line is the road log, the route that the pre-meeting field trip took from Port Allegany to the field conference headquarters in Williamsport. And that's a part of the chapter that I mentioned. You'll see at the end how to find that chapter online. It includes that road log. We'll look at the area inside the red box next. The upper left map is a geologic map. It shows colors indicate different ages of bedrock, Pennsylvanian being younger, Devonian being older in this area. And you see the black line, that's that field trip route that has a road log. You'll see Kane. Wilcox is a place I'll mention in northern Elk County later on when we talk about Kane Chapel. So notice the big change in the bedrock across this area from east to west. I'm going to talk through the geologic origin of that and what that means for land use change across this region. There's a cross section here, AA prime, that shows we go from the intensely folded Appalachians here across the Allegheny front here into the folded but less folded plateau. And you can see how that happens here. There's a detachment, like a rug on a hardwood floor, more folds above this detachment than below. And these upward folds from that tectonic event 300 million years ago are cored by Silurian age salt and weak shales, and there's less of it in the low parts of the folds. Um, the effect of that on the terrain is that today, the low parts of the folds in this area have preserved um, areas of Pennsylvanian rocks, including Pottsville sandstone in this blue-green color, which includes quartz-rich hard sandstones that are very resistant to erosion. So those are actually the uplands now. And the Pottsville doesn't typically make great agricultural soils widespread, so those tend to be forested uplands. These are the valleys now. They're the upward folds, but they expose the older Devonian rocks that include lots of shales, especially in some of the rock layers within the Devonian. And in those, there are lots of croplands. So the land use is different, the terrain is different. Um, Forested uplands typically, and more farmland, more cropland in the lowlands that are the upward parts of the folds. Kind of inverted topography here. And notice how that changes across the area. That here there's a lot of Pottsville Formation outcrop, lots of forested areas, less cropland agriculture there. The change here is thought to be because the thickness of Silurian salt decreases across here from east to west. So the nature, amplitude of the change of folds from that tectonic event changes, and we don't have that differentiation between Devonian uh, uh, and younger rocks. There are still Devonian rocks exposed in stream valleys in places. You can see the brown here, but not as widespread as to the east. So hopefully that'll help you understand the difference in land use coming into the Pennsylvania wilds here. I mentioned the formation of Pine Creek Gorge. I wanted to talk about the Allegheny River Valley at Kinzua Dam here. Notice east of Kinzua Dam, the arrangement of the valley and tributaries indicates originally northward draining valley system here. It gets broader and older to the north too. And to the west, the same thing. This valley system indicating original drainage to the north. Those drainages being cut off, and as with Pine Creek Gorge, glacially aged watershed divide being overtopped and cut down in glacial times, in Pleistocene times, so that where Kinzua Dam is sited is an especially young, steep-sided, narrow part of the valley where the dam was located, whereas the reservoir is in a wider, older valley with a flat floor. Then the map on the upper right is a map of conventional oil and gas fields, those having been developed through mainly vertical wells, relatively shallow wells, thousands of feet deep. But this is not an indication of shale gas development in more recent years. These are the older conventional fields that would have been important in the glassmaking industry in McKean County. Notice how they're long, the elongation of them, and those fit the anticlines. They're typically on the upward folds or the anticlines in the subsurface geology. And they change from oil fields here, oil and gas fields mixed where Kane is, to the area around Port Allegany with some natural gas fields that fueled the early glass industry in Port Allegany. So this geologic feature was important to glass making there, which was important to the Allegheny Modernism architecture. In McKean County, the northern part here, Bradford Field, was actually the world's first giant field. It was the first oil field in the world to surpass 100 million barrels of oil production. So an important, very important area, and you can see the outline of it here on that map. The reason for the change from oil fields to gas fields, these fields are derived from organic rich shales loaded with algal-marine organic matter, fossil organic matter. And when it's buried, it can form oil, buried more deeply, changes, cracks to natural gas. And you can see from the dashed line here, a reconstruction on that cross section that was more overburden. There were more rocks and sediments originally on top of the surface here than farther to the north, getting away from the Allegheny front. And so that relates to the source rocks in the subsurface for oil and gas changing from oil in this area to natural gas down here. Some of you will be interested, especially in the Marcellus level, in the Middle Devonian, in the green band here, and you see it's affected by that tectonic deformation from 300 million years ago, whereas the Utica in the Ordovician is below that detachment and is less affected by that deformation. The last thing I'll mention on the oil and gas fields map are the brown fields. Those were originally natural gas fields that were depleted and now are used for seasonal gas storage, including Leidy Field down here. Okay, let's take a little bit closer look now to the Port Allegany Roulette area. There's a geologic map of that area. It's the same color scheme as before. You can see that Pottsville formation and the kind of blue-gray or bluish-green here. And notice at Lynn Hall, next to Port Allegany, we go to the top of the mountain behind Lynn Hall, and it's capped by Pennsylvanian Pottsville sandstone that, as I mentioned, includes really quartz-rich sandstones, helps it hold up the high terrain in this erosional landscape. And there are boulders of Pottsville sandstone, the boulders resistant to erosion, that are on the sides and in the bottoms of steep valleys below these hills or mountains that are capped by Pottsville sandstone. And this valley especially, but some others around Port Allegany, served as sources of boulders that were the silica supply for early glassmaking from the 1890s for some glass companies into the 1920s in Port Allegany. Also, boulders of Pottsville sandstone were split and used as building stone here and also other parts of McKean County. It wasn't quarried. There were enough boulders at the surface in this area that was surrounded by glaciers. Part of the reason there's so many boulders is the periglacial, the nature of the climate here as glaciers came and went. And there were lots of freeze-thaw cycles and permafrost at times, and then melting, enabling large boulders to move downslope and forming landscapes covered with boulders. So that has to do with the geology too, and the ancient climate. Notice then the purple here changes names going across this gray band. It's probably Upper Devonian in age, maybe in part of the map area, it could be Mississippian in age, but that changes across the gray band here from a more non-marine unit to a more offshore or saltwater marine unit across that gray band. And that's an interval where lots of flagstone was quarried around Port Allegany and elsewhere. So that's an important unit for us that around Port Allegany and behind Lynn Hall is according to the regional map, likely dominantly marine. Notice the Catskill Formation in brown here in the Devonian. The Catskills, a mostly non-marine unit. It's red in color. It has lots of river channel sands and floodplain shales, but it's overlain by a unit that can be marine. It's underlain by a marine unit. So the very base and top of the Catskill can be transitional marine. Let's talk a little bit more about the geology of the flagstone because it's such an important feature at Lynn Hall and in Allegheny Modernism buildings. Here you can see a map with the outline of Pennsylvania as the land is thought to have been 360 million years ago in the late Devonian. There was another tectonic event, an earlier one to the east with mountains, rivers of the Catskill Delta, coastal plain area, and then an inland sea. And at times, the inland sea flooded in. At times, the deltas won and pushed the inland sea away. And the Catskill Formation in this geologic cross-section, this is meant to show the changes laterally at a given geologic time. Geologic time is a flat line here. This is flattened cross-section, not a structural cross-section like the one we saw before with present-day elevations. The Catskill Formation non-marine rocks change laterally to marine rocks going from east to west. You can see that the marine rocks come to the east at times as this interior sea flooded in, and there's another transition from dominantly non-marine to marine here. This is a section, vertical section of the rocks around the Lynn Hall area. Same color scales as before. The mountain behind Lynn Hall capped by Pennsylvanian Pottsville Formation. But behind Lynn Hall, there are quarries at these levels in this unit that's colored lavender on the maps and is probably Upper Devonian in age, maybe a little bit Mississippian, underlain by the Devonian Catskill Formation. The flagstones themselves from the area around Lynn Hall and as well as eastern Potter County adjacent have a variety of colors. So these are arranged not by age within the formation, not by geologic age or position within the formation, but just arranged by color and tone. In the Catskill Formation, I've seen flagstones that are medium to dark gray in color, like bluestones quarried from rock units far east in Susquehanna County still today. Some are a little bit purple in color that's called lilac. Some are medium grays, lighter grays. Some are even olive green or light green. And then in this unit colored purple, probably Upper Devonian in age, that was quarried behind Lynn Hall and other areas around Port Allegany and western Potter County. The flagstones there range from olive green in color, olive gray in color, to lighter greens and even yellowish green. We'll look a little more closely at flagstones that were quarried around Port Allegany, as well as flagstone from a quarry that's next to a road cut on Route 6 near Roulette in western Potter County. And here you can see that the olive green flagstone is the color that was quarried behind Lynn Hall, on the hillside behind Lynn Hall. You can see that where that is in the stratigraphic vertical column of rocks and in this schematic cross section too. And then there's lilac flagstone around Port Allegany, not only from the bottom part of the Catskill, but also, or that's near Roulette, also from Port Allegany area, from the upper part of the Catskill, there's this lilac, a little bit purplish color flagstone. And this lilac flagstone is a very special thing. It was sold, has been sold not only domestically within the US, but for export too. And in recent years, it's even been exported to places like Japan. It's such a special material. These are pictures from the quarries behind Lynn Hall. We can see their locations on this shaded map of elevation. There's Route 6. Here's the main building of Lynn Hall. There's the cottage. On the hill behind, there's a lower, middle, and upper quarry that you can see here. The upper quarry photos at the top, middle quarry, and their lower quarry photos at the bottom. The fine-grained sandstone here is dominated by planar parallel lamination. And the layers here, uninterrupted by mudstone layers. The sandstone layers can be 10 feet thick or thicker. And with all this lamination, the stone could be split as thick or as thin as was wanted. Flagstone slabs for pavers typically being split to widths of thicknesses of an inch to an inch and a half. So it was a premier building stone. Naturally non-skid fine-grained sandstone could be split to the desired thickness. Notice this texture. It's called parting lineation. So when the stone was split, you can get a sense of the internal fabric of the sand grains by this texture. The sand grains are oriented more or less along this fabric, this parting lineation. The little sand grains were oriented by the water currents that deposited them. So seeing this lineation, this parting lineation fabric tells us that the water current that deposited the sand hundreds of millions of years ago flowed either this way or that way. You can't tell which way. In the lower quarry there's another feature that occurs sometimes in these flagstone quarries where it's not just planar parallel lamination, but the laminations are tilted down to one side, in this case down toward the right. This is the front of an ancient underwater sand dune. As the sand dune grows, it grows along the downstream side of it. These parallel laminations pass forward through time so that this inclination tells you that the ancient water current that deposited this flowed from left to right. There's another feature that's seen in a few of the hundreds of pavers at Lynn Hall of this olive green flagstone, but only a few. And you can see these little circles. Those are traces of life, probably from a marginal marine setting, vertical burrows of marine life. And those, there are only a few slabs of those, and they're preferentially displayed in places that were high traffic on the steps leading into the main entrance of the core and at the top landing of the steps inside, too. So not a lot of those, but maybe some indications of a marginal marine setting here, which is consistent with the regional map that we saw for that purple unit. This is a different outcrop now. This is in eastern Potter County at Roulette. You would have seen on the maps. And this now is from the lower part of the Catskill Formation. It has marine mudstones and sandstones thin bedded below it here in this schematic cross section, here in the outcrop, that are full of traces of marine life. Not fossil shells that I've seen, but traces of things moving through the sediment, marine life moving through the sediment. And this is a really special area. And the reason I'm showing it to you is because it has an active quarry, but you can also see what happens to the flagstone rock laterally. Most of the quarries, all the abandoned quarries that I saw around Port Allegany, people stop quarrying when they ran out of flagstone. Laterally and going down, they don't run out of flagstone. You don't really get to see the relationship between this parallel laminated flagstone and other rock types that would help you understand better the depositional environment. And this parallel laminated flagstone has been studied for a long time, many decades, and people have interpreted in northern Pennsylvania and southern New York that it was deposited as kind of the tops of sandbars, either offshore sandbars maybe at the mouth of a delta where sand's being deposited quickly, or sandbars in between channels in a river in a non-marine setting. So all of those environments have been interpreted for flagstone deposits across the northern Pennsylvania, southern New York region of flagstone. In this case, here you can see my compass pointing north for scale. There's that parting lineation I showed before. Here are the measurements of it. You can see it's oriented this way. And in this outcrop, this is a section that's flattened on this level. The rocks actually tilt down a little bit structurally, part of that folding we talked about, broad folds. But if you look at the rock layers as they were deposited, lateral equivalents to flagstone here in the road cut in front of the quarry have a lot of channeling, evidence of those sand dunes that we talked about before. Here's a sand dune from in the quarry that shows that the current that deposited this flowed from left to right. And when we measure those, we can see there's an orientation here, flow to the southeast, parallel to this parting lineation. And we can see the lateral change here. I'll mention that this cross section is highly expanded vertically. This is 30 feet vertically in scale. This is 600-foot breadth of the road cut. So it's quite a bit expanded laterally. And here's an image of the terrain. There's Route 6. There's the road cut with the interpretation superimposed on it of those different rock layers. This one having lots of flagstone. This one having lots of features of channeling, scour, and fill, as though it's in a part of a river channel. Here's the quarry behind the outcrop. It's private property, so one mustn't visit it without permission, but luckily I got permission to study it, and I'm grateful for that. So you can see that the lateral change here in my interpretation of this is that it's the fringe of the mouth of a river channel in a delta, that there's a channelized part of it toward the axis of the channel, and then that the flagstone is deposited on the fringe. So there's an example of a marginal marine setting for flagstone, an interpretation of one anyway, although there are others that could be interpreted, and it doesn't mean that all of the flagstone in Port Allegany was deposited in this environment. Again, people have interpreted offshore bars, sandbars with sandstone created that has parallel lamination and other environments too. And some have more of a tidal influence than others. Okay, let's move to the sandstone blocks and talk about the geology of those now. Those light colored Pottsville Formation blocks that we saw. The red dot on these maps is the location of Port Allegany, and they indicate what the terrain might have looked like, is interpreted to have looked like 310 million years ago during deposition of the Pottsville Formation. There you can see Port Allegany is close to the equator at that time. Here's that mountain belt off to the east that created the folds of the Appalachians that I mentioned, the folds in the plateau area too, collision between Northwest Africa continental plate and North America. And we're in the area where there are rivers coming from those tectonic formed mountains, and also rivers coming from the low-lying craton area, not as high mountains there, and maybe that would provide more of a quartz-rich source for the sediment. You can see people's interpretation of the orientations of rivers coming into an inland sea with deltas in between. And so we wouldn't be surprised to see rivers that flowed around Port Allegany at this time to the southeast, more or less. We'll look closely at some Pottsville sandstone outcrops and boulders around Lynn Hall. And I'm showing these maps to orient you to where we'll look next, but also to point out that there's a road log to visiting RV hall designed buildings in Port Allegany that's part of the field guide chapter that I'll mention at the end, where you can find it with the 2025 Field Conference of Pennsylvania Geologists. So you could really spend a day looking at these structures, maybe going a little farther afield, looking at some at St. Mary's. There's one I'll show you that's near Lewis Run, farther to the west as well. You really could make a day of it looking at these buildings, some built by Walter Hall, designed by RV Hall. The stop 4 on this is Lynn Hall. It's not open for public tours currently, but it's seasonally an Airbnb with 3 units, and I'll talk more about that. This year, here we are in early November, it's currently closed, but it's typically open from the beginning of April through October. This is the mountain behind Lynn Hall, and I mentioned the top of the mountain here is Pottsville Formation outcrop. It's mostly covered with boulders, armored with boulders, but there are a few outcrops of bedrock in place there, and I'll show you pictures of a couple of those. As I mentioned, there are boulders of Pottsville sandstone all down through the steep-sided valley and others like it in the area. And there's an alluvial fan with, I'm sure it had Pottsville boulders in it too, down at the level of Route 6. And as I mentioned, there were boulders of Pottsville sandstone harvested by farmers, carted off starting in the 1890s to glassworks nearby in Port Allegany and used in early glassmaking there. So first we'll look at outcrops. And here are a couple of outcrops in State Game Land 61. So it's on on public property. I don't see any road. I don't even see a trail or a path that goes to this. It's a pretty quiet spot, nice spot, one of the cleanest game lands I've seen. Really didn't see any trash anywhere. And this really nice rock formation has these deep pits in it, deeply pitted, weathered through a very long period of time. Again, it's quartz-rich, hard sandstone. It doesn't really dissolve in natural waters at any appreciable rate. And where I've seen similar Pottsville sandstones that where the timing of exposure of the bedrock has been age dated, they suggest that this deeply weathered sandstone probably was exposed for many, many thousands of years. So a really old landscape feature on top of the mountain near Port Allegany. And it sits, as you can see, in a hemlock grove. It's really a lovely spot. Here's a nearby outcrop. You can see some large-scale cross-lamination indicating that the ancient river current that deposited this 310 million years ago was flowing in the photograph from left to right. There's a mason's hammer circled for scale. So I measured paleocurrents here pillar orientations in other outcrops around Port Allegany too. And they indicate, although there's a lot of dispersion, flow direction, average flow direction, more or less southeast was indicated by the regional map. These are boulders in the area of the box I showed on the map. And the boulders often have a gray, weathered exterior, but typically inside they're a golden brown color. This is the most common color of these. And you can see there's some iron mineralization concentrated on the surface of this boulder as it slowly weathers through time. Irons become more concentrated there. Some boulders are entirely very light gray, very quartz rich without much in the way of other impurities, other elements than silicon dioxide quartz. And sometimes those occur on the tops of those really ancient outcrops where water has dissolved, taken away all the iron mineralization and left behind this light gray sandstone, really rich in silica. Another kind of weathering rind, though, that was less common is this pink or red color. The interior of this stone is this golden brown, the common color here. This is the exterior rind, and there's this weathering rind of iron mineralization that's a bit pink or red. This was of special interest because of the beautiful pink sandstone blocks in Pottsville Formation sandstones at Kane Chapel that we'll see later in the presentation. Here's another one of these weathering rinds, pink in color in the dappled sunlight of the forest here. So a special feature of those, but most commonly they're this color. And again, boulders like these are what were harvested for the Pottsville sandstone light colored blocks that we saw in Lynn Hall and other buildings around Port Allegany and McKean County. I think matching colors from boulder harvested rocks might have been a pretty challenging thing, especially if you were looking for colors that weren't just golden brown like this. I mentioned that from the 1890s, for some manufacturers into the 1920s, they were using local Pottsville sandstone boulders as a silica source for glass making in Port Allegany. And here you can see the bottles that were made using that local source. A bit of iron in the sandstone gave them a light green color, kind of like a Coke bottle color. But then when manufacturers started using more silica-rich distant sources, maybe the sand supplied by rail, then they started making glass that was completely clear. And today, there's still glass making in Port Allegany. There's a major glass works there that makes glass containers. This is one that they've made in recent years, perfectly clear with that more distant, more pure silica source. So a geologic feature of the glass made in Port Allegany in early days. Let's look more closely now at Lynn Hall. You can see the core here on the right, the addition built during and after falling water on the left. And here's the entrance to the core. Beautiful stonework by Walter Hall, those flagstones from the hill behind Lynn Hall. Now you know all about the geology of the Pottsville sandstone too. I'll point out how nicely matched the sandstones, closely matched they are here. That had to have been difficult using boulders as sources for those. And then stone pavers too, and those burrows that we saw came from these pavers near the entrance. Here's a wall I showed earlier, part of the core, part of the reason Walter Hall was asked to serve as builder at Falling Water with the addition off to the side. If we go inside the core, this is the lower level, beautiful common area, beautiful flagstone floor. It's a different color than olive gray though, because it's coated. That makes it darker in color. But you can see the olive gray flagstone, the sandstone blocks blended together here in this typical Walter Hall style stonework, in this case without stickouts. And notice the corner window has a vertical metal support in this core, the exterior of which would have been built before Hall served as builder of Falling Water. Here we're transitioning from the core to the addition at Lynn Hall. And there are two units here that are part of the Airbnb. The architect's suite, we'll look at that first. Long row of windows, typical of Allegheny Modernism. And then we'll look at the apartments upstairs from that. So let's go through the door here inside and take a look. And here's what we see, the long row of windows, typical of Allegheny Modernism, also typical of Frank Lloyd Wright Usonian designs. Look at the floor here. These flagstone pavers from behind the house, all different sizes and shapes. That's a feature in common with many stone floors in Frank Lloyd Wright houses from the organic design period. And we talked about how that fits that organic design philosophy described by Kevin Newt, each unique, but also at the same time part of the greater whole of the floor, part of the greater whole of the house. Typical Walter Hall style stonework here, slabs and blocks. Notice this is a corner window and there's no metal support. It's glass on glass. That's a mitered corner window, much like one that we saw at Fallingwater. And again, this was built uh, after the main building at Fallingwater, the addition was. If we move upstairs, another beautiful stone firework, typical of Walter Hall's work. And notice the mitered glass corner window here as well. There's flagstone under the carpet. We'll see that on the next photo. Notice the glass block. So glass block is one of the typical features of Allegheny Modernism designs by architect R.V. Hall. Glass block was made in Port Allegany by Pittsburgh Corning from the 1930s up to 2016. And for decades before 2016, Port Allegany was the only U.S. source of glass block. So that was a special thing in Port Allegany. And glass block and other patterns of glass that I'm not showing are important features of Lynn Hall, and also glass blocks, an important feature of Allegheny Modernism designs by R.V. Hall. If we turn around, this is the view in the same room. You can see the flagstone pavers, but look at this window, really blurring the boundary between inside and outside, bringing nature inside, and the same building material being used inside and outside, just like at Fallingwater, just like at Taliesin in Wisconsin. Beautiful Walter Hall style stonework, includes stickouts, and again, you can see use of glass block, typical of Allegheny Modernism designs by R.V. Hall. This is the cottage, separate building up the hill. It's another of the three Airbnb units. And the original part of this was built during the gap year at Fallingwater in 1938. You can see the typical Walter Hall style stonework, a blend of Pottsville sandstone blocks and flagstone slabs. More variety in color, though, than we saw at the entrance to the core here. This part of the cottage was a much later addition. Some bedrooms were added. This is the original part. And this really is similar to Usonian style houses by Frank Lloyd Wright with a flat roof on horizontal lines. There's even a cantilevered element here with a prow, another element common in some other Allegheny Modernism designs by R.V. Hall. And there's a mitered glass window in the corner. Moving to the inside, this is that prow element, the mitered glass corner windows over here, but I wanted you to see the fireplace, the beautiful stonework of the fireplace, this stone of the floor here as well. So typical of Allegheny Modernism, but also with elements in common with Frank Lloyd Wright, organic architecture, and Usonian designs. Moving inside the core at Lynn Hall, there's an interior water feature you can see here shown in the nice photo in the upper left. Lots of natural stonework there. This wall is up against the hillside, and there was a natural spring that fed this interior water feature that would have been built in the core most likely around 1937 when Hall was finishing the interior. As I understand it, Lynn Hall had a restaurant for a long time, a public restaurant, and as I understand it, there were trout in this spring-fed water feature at that time, and one could pass by here and pick out your dinner on the way to the restaurant. Similarly, there's an interior water feature in Fallingwater too. This is at the end of the bridge that connects the main house built in 1936 and 37 with the guest suite and staff quarters built in 1939. So this bridge would have been built in 1939 after the core at Lynn Hall, and it includes an interior water feature, especially after rains. There will be water flowing across this stone. So an interior water feature in both sites likely having been built, one of them being built earlier, likely in the core at Lynn Hall. I wanted to show the breadth of representative designs, Allegheny Modernism designs by R.V. Hall on a map. And you can see that they're concentrated in northern and western Pennsylvania, but there's some in southern New York also and other areas. There's one in Virginia, an R.V. Hall design building there. He designed residences in Connecticut. He had designs in the Caribbean, not shown here too. But the core of his Allegheny Modernism work was in the Allegheny Plateau and Allegheny Mountains in Pennsylvania and New York. The yellow indicates buildings that I've been able to verify were built and that include significant stone components. And the ones with bold outlines on the symbols and bold font are ones that I'll show. We've seen some already from Port Allegany. I'll show you another one there. But we'll look at some buildings in Lewis Run. We'll look at one in Pittsburgh, State College, Lancaster, and St. Mary's as well. So we'll show some representative examples there. We'll go chronologically, and this is a very early Usonian style design or Allegheny Modernism design. This was designed in 1937 in the architectural office of Thomas Hendricks. Thomas Hendricks was a Cornell grad. He set up an architectural practice in Bradford in northern Pennsylvania, and R.V. Hall went there and served as an apprentice. So the original drawings for this from 1937, they're drawings both by Hendricks and Hall, R.V. Hall. It's interesting because this has Usonian design features in common with Frank Lloyd Wright buildings, the long horizontal lines, the rows of windows. There's even a mitered glass corner window here. It doesn't have a flat roof, but it has a low pitch roof. And some Usonian style houses by Wright did have low pitch roofs. For example, Kentuck Knob is thought of as a grand Usonian design. The house there has a low pitch roof, not flat. So it has features in common with Usonian designs. And remember, I showed that Jacob's One house. That was Wright's first Usonian house, the one that's on the UNESCO World Heritage List, built in Madison. Well, that was built just 30 miles away from Taliesin, where Walter and R.V. Hall visited with Frank Lloyd Wright in January of 1937. In January, Wright was working on the design for the Jacobs One house. Construction didn't start there, as I understand it, until mid-1937. And it's hard to imagine that the halls wouldn't have been exposed to those design concepts. In fact, later, um, uh, Wright wrote to Walter Hall and sent him a generic materials list for a Usonian house to get a cost estimate from Walter Hall. So there was exchange of information certainly through that period. So this was a very early design, Usonian style or Allegheny Modernism style building. Obviously, I probably don't even need to mention, you can see the good stonework here built by Walter Hall. And there are a couple other buildings on the grounds of McKean County Memorial Park, cemetery in central McKean County. I mentioned that the architectural drawings for this exist, owned by the owner of McKean County Memorial Park. And the owner, recognizing the importance of these, the architectural significance of them from this early period, the owner has agreed to archive them with the Carnegie Mellon University Architectural Archive. And the archivist at CMU, recognizing the importance, the architectural significance of this building and those hand-drawn drawings, has agreed to accept them. So these should be preserved for people to study, research in the future. And when CMU has these in-house, we're making an inventory of them before we transfer them to CMU. There should be digital images of those drawings made available online publicly too, just as there's an R.V. Hall drawing collection there that was part of the way I learned about different locations of R.V. Hall design buildings in the CMU Architectural Archive with online drawings. Walter Hall built a couple other structures at the McKean County Memorial Park. The Singing Tower you can see here, those are also part of the designs from the Hendricks firm. And there's an entrance, towers, and a wall. This is one of those that you can see built by Walter Hall. So there are drawings of those also. And as I said, the drawings were made in the Hendricks architectural practice. Some of the drawings are by Hendricks and some are drawn by R.V. Hall. So he certainly had a lot to do with these designs, and his father was the builder here. The Singing Tower still plays music from the top. It's very nice to be on these grounds and hear that. It's not the only one of these that was ever built. There's a Singing Tower in State College. There are some others in other places. But the architectural drawings, I think, help us understand the intent of this. There are a couple of drawings hand drawn with very fine pencil lines that radiate upward from the top of the tower, not down to the ground to us. So it seems from that one could interpret that the intent was that the music played here was meant to project heavenly, that it was perhaps to sing God's praises or communicate with those who've passed. So those drawings, not only architecturally significant, but I think can help understand the art and intent of these buildings too. Going chronologically then, here's another house, this one from 1939, the Scott House in State College. You can see the beautiful Walter Hall style stone walls, bit of variety in this sandstone block colors, but those darker flagstone slabs. Notice how there aren't many windows on the front and the entrance is sort of hidden here. The entrance is around the corner here. That Allegheny Modernism here has that in common with Frank Lloyd Wright designs, including at Fallingwater. But when you go to the back, lots of windows. Here, the living room, there's a mitered glass corner window. You can see this beautiful Walter Hall style stonework. Also notice the glass block here, a typical Allegheny Modernism element. Here's a house that was designed as a collaboration between Philip Hallock and R.V. Hall. And part of the reason I'm showing this is to indicate that R.V. Hall wasn't the only architect who designed in Allegheny Modernism style. Philip Hallock was trained in architecture at Penn State, and he and his wife were in Port Allegany. He worked at Lynn Hall in an architectural office in collaboration with R.V. Hall from 1939 to 1941. And this is from a publication from 1943. You can see these black and white images. And then here's the color image I talked before about the metamorphic rock from southeastern Pennsylvania. It's still quarried down there, still available with green flagstone that likely could easily have come from Port Allegany or even the hillside behind Lynn Hall. So typical Allegheny Modernism lines, many in common with Frank Lloyd Wright's Usonian designs. Here's an architect's perspective color view. After collaborating at Lynn Hall with R.V. Hall, the Hallocks moved to Chicago, where Philip practiced architecture. During that period, Philip and his wife are said to have traveled west to Wisconsin, visited with Frank Lloyd Wright at Taliesin, shown his portfolio, which very likely would have included the drawing of the Morehouse house here in Lancaster. And it's said that Frank Lloyd Wright, maybe in jest, maybe not, said something like, "When are you going to join my fellowship?" Well, that didn't happen. Halleck went back to Chicago, and he served in the Navy during World War II up to 1947 when he and his wife moved to State College. And later I'm going to show you the building he built for himself and his wife in State College. So a very nice house that still exists in Lancaster. The Simon's House in St. Mary's, similar kinds of features. Notice the use of glass block here, typical of Allegheny Modernism. Stone floor, stone walls, typical of Walter Hall work. This is in Port Allegany itself. Catherine Street is one of the stops on the road log in Port Allegany that I mentioned as part of that chapter of the Field Conference Pennsylvania Geologist Guidebook. Here you see the typical Walter Hall stonework, a typical R.V. Hall Allegheny Modernism design with these long rows of windows, including glass block. Here's one that's north of Pittsburgh in Wexford. It's said to have had a view of North Park, designed by R.V. Hall. And you can see the typical Walter Hall style stonework, interior and exterior, long row of windows here too. Here's the house I mentioned before when the Philip finished his Navy service after World War II. In 1947, he and his wife moved to State College, and they built this house, it said, on a stone quarry, using some of the stone from the quarry in the house. You can see the typical Allegheny Modernism features of this, though, including stonework with that Lynn Hall or Walter Hall style blend of darker flagstone slabs with lighter sandstone blocks, both interior and in the exterior. Now, Philip had a career beyond this. After practicing architecture in State College for a few years, he joined the architecture faculty at Penn State, where he served for decades. And his architectural style evolved away from Allegheny modernism eventually. And he even remodeled this house. That's why I'm calling it Hallock House 1, because it did become remodeled later on. And he evolved into a different architectural style. But he was a part of Allegheny modernism beyond RV Hall. This is RV Hall. These are RV Hall parts of Port Allegany High School. RV Hall designed, built in 1956, and then an addition in 1962. There was a later addition in 2001. I'm not showing that part. So 1956 was after Walter Hall had passed, and you can see that there's green flagstone built into walls here, including some stickouts, but it's not a blend of sandstone blocks and slabs that were typical of Walter Hall work. Notice the classrooms here almost cantilevered out. There are a lot of Frank Lloyd Wright type of elements here. Notice the use of glass block here and in these classroom windows as well, typical of Allegheny modernism. And I'll point out that although there's not sandstone blocks here, light colored used, they're light colored bricks, almost salmon colored, similar in color to the core at Lynn Hall, combined with this green flagstone. Could easily have come from the Port Allegany area. Notice the patterned blocks here. Those were another element typical of RV Hall design schools. The other schools he designed, each school had a special and unique pattern of these, but these are very reminiscent of the textile blocks Frank Lloyd Wright built into houses in California in the 1920s. So lots of Frank Lloyd Wright-esque features in this school where pupils go to school every day. I hope you've enjoyed this foray into Lynn Hall, Allegheny Modernism architecture, echoes of Frank Lloyd Wright architecture across Pennsylvania and southern New York and other areas. I'd like to move to talk about the Kane Chapel where the talk was given a few days ago. Here's an exterior view from the street, built by Thomas L. Kane, originally as a Presbyterian church. And now it's known as the Thomas L. Kane Memorial Chapel. Kane is actually, his remains rest here, kind of nestled, surrounded by the building, not inside, but surrounded by elements of the building. And here we see the north and west sides of the building have lots of pink sandstone. There were publications about the geology of McKean County and surrounding counties by Ashburner in 1880, by a fellow named Stone, Building Stones of Pennsylvania in 1932. They both talked about this building and the pink sandstone here, saying that it was Pottsville sandstone from the upper part of the Pottsville Formation that came from near Wilcox, we saw on one of those maps. And one of the publications, the Ashburner one, calls the upper part of the Pottsville Formation down there the Johnson Run sandstone. There's a Johnson Run not far from Wilcox. Johnson Run sandstone at the top of the Pottsville, including pink sandstone like this. Now, it's a very special color, as I mentioned before. I didn't find whole blocks of this around Port Allegany. And a few of us from the Historical Society here went to try to find this in place where it was harvested as building stone around Wilcox. And I don't think we quite succeeded in finding a lot of this in place, but we learned some things and we have some ideas for other places to look. And I'll mention that one of the references here mentions that the sandstone for the chapel came from Clay's Quarry near Wilcox. So if anybody knows where Clay's Quarry was near Wilcox in this Upper Pottsville, Johnson Run sandstone, so-called, I'm sure the Historical Society folks and I would be very interested in knowing. And here you can see I'm using my old school color comparison chart to characterize the colors of these blocks, some more orange, some more pink, and some are very light gray. We'll look at this wall on the front of the building and especially close look at this block. And the left side of the block, I think, is the original color. And the right side of the block, I think water has flowed through it and dissolved away some of the iron mineralization and left it a lighter gray color. And you can see the boundary of that dissolution. There's actually more iron right on that boundary between the original stone and the stone where iron's been dissolved away, either underground when the stone was underground or when the stone was a boulder on the surface. And it's not unusual with this Pottsville sandstone to see bands of more and less iron mineralization as water flowed through and moved the mineralization around a little bit. This is the east side of the chapel. The side to the left, the south side, is similar in being dominated by light gray sandstone. And the publication in 32 suggested that maybe this once had a lot of pink sandstone on it that has changed to light gray. And I can't tell that that was the case. Around the corner, I did see a sandstone block on the corner, not protected by the eave, but exposed to weathering. And the same block was pink on the south side and on the west side, and surrounded by gray blocks on the south side. So I'm not 100% convinced that it wasn't built this way. The pink blocks were concentrated on those two sides where we saw them in the previous photo, but that's something someone wrote about almost 100 years ago and may be the case. So here's how to find the publication that has a lot of these illustrations, a lot more information about Allegheny Modernism and geology. If you go on the Field Conference of Pennsylvania Geologists website, you look for the place to download guidebooks, and the 2025 meeting, you click on guidebook, as I show with the arrow. It's not in the road log, it's in the guidebook, that chapter about Lynn Hall and Port Allegany geology. And there have been annual meetings and guidebooks for decades. So there are many of these available for other parts of Pennsylvania. If you want to learn about more geology, you can root around and look at those. There's even a map of where those guidebooks have descriptions of the geology. Here's the first page of the chapter. It starts on page 12 of that guidebook. There's the citation for it. Go to fcopg.org to find these guidebooks and that chapter, which is available for free online. Clinton Piper is a longtime staff member at Fallingwater and with the Western Pennsylvania Conservancy is really an expert in the architecture of Lynn Hall. Clinton wrote the National Register of Historic Places nomination form for Lynn Hall, and I learned a lot from that, from Clinton's work on that. Well, he's learned a bit more about the work of Walter Hall and Raymond V. Hall, and he gave a talk this year in September. It was at the annual meeting of the Frank Lloyd Wright Building Conservancy, which was held in Pittsburgh this year. That talk was recorded, as I understand it, and should become publicly available in about a year from the talk being presented in September. So look for this to be available potentially publicly in late 2026. If you'd like to read more about the geology of Fallingwater, it's a chapter in the Geological Society of America Field Guide 66. If you search for that online, you'll find that you can buy the whole paper guidebook, or that's one chapter, or you can buy a PDF just of the chapter about Fallingwater geology. I think the PDF's about $10. Similarly, there's a Geological Society of America Field Guide 71 for a section meeting that was held in Erie, Pennsylvania. And that guidebook, again, you can buy either a paper copy of the whole thing or just a PDF of the chapter that is about the geology of Frank Lloyd Wright's Gray Cliff on Lake Erie. There also are some talks you can listen to. There's more detail about the geology of Fallingwater in a Fallingwater webinar from about a year and a half ago. You can find that by searching for Fallingwater webinars, or there's a Fallingwater channel on YouTube. The talk is available there, or if you just Google Fallingwater geology, you should be able to find it. That one was meant for the public. I used written text for that. It's less conversational and has more precise language than this talk. And it's quite a dose of falling water geology, not only the building stone, but the terrain and how the building fits into the terrain as well. Then you can see a couple of talks that were hosted by the Harrisburg Area Geological Society, one that focused on falling water last year, one from early 2025 that included a bit of falling water, included a bit of Taliesin in Wisconsin. It's the only talk I've given so far that was recorded and publicly available that has a bit of geology of Gray Cliff and a bit of the geology of Kentuck Knob as well. Those, though, were delivered to geologists, talks given to geologists. So I used the geology terminology without explaining it, without apologizing or explaining the terminology. Then I wanted to convey what I learned about the geology of Taliesin and nearby hillside that I talked about before in southern Wisconsin, both available for public tours. I wanted to convey what I learned about those last November when the folks there hosted me to study the geology to the docents and staff of Taliesin and hillside. So I made a talk and made it publicly available on YouTube that focuses on those. If you want to learn more about the driftless terrain and the geology of the building stones of those two Frank Lloyd Wright sites, that's available on YouTube. If you search Fred Zelt on YouTube, you'll find them that way. I think if you search Taliesin geology, you should be able to find it that way too. Then a few years ago, as a volunteer with a nonprofit in Pittsburgh, I led bike rides on each of the 25 trails longer than 10 miles in Western Pennsylvania, from top to north and from east to west. And to supplement people's experiences on those bike rides, with the trails shown as dots in the map here, I made a series of 6 talks about the landscapes and terrains, the geologic underpinnings of the landscapes and the bedrock geology and land use. And there's one that it covers the Pennsylvania wilds, the area circled in green. It's this one of the talks. So you should be able to find the 22 and 22 Pennsylvania wilds talk from 2023. Again, if you search Fred Zelt on YouTube, you'll find it in that channel. And you may be able to search other ways and find that too, to talk about the geology and land use of the Pennsylvania wilds, including the McKean County area. So I hope you've enjoyed this talk. I hope you'll be able to go out and visit some of these great sites. And I plan to study Taliesin West early next year. There's maybe one more stone Frank Lloyd Wright site I hope to study, and then maybe that'll be a wrap for me. So all the best to you. Take care.